Respected sir or madam, I welcome to you in this demo video. Today I am gonna discuss about an important chapter, that is motion in one dimension. This is the second chapter of class 9 ICSE physics. So this is the first part and this video is presented by me. These are the brief introduction about myself. Now what we'll study, what we'll learn in this chapter. We'll learn about physical quantity. Next we'll learn scalars and vectors, then rest and motion, and the last distance and displacement. Now coming to the first slide, the physical quantity. Just you can see what is physical quantity. This is the first important question. What is physical quantity? Physical quantity is a quantity which can be measured. A quantity which can be measured is called physical quantity. I have a smartphone, so I can measure the length of the smartphone. I can measure the breadth of the smartphone. I can measure the thickness or height of the smartphone. I can measure the mass of the smartphone, right, with the help of a digital balance, right? So these things, I mean to say length or mass, these are the part of measurement. So we can say that these are the physical quantity. Okay, but if I say this phone itself is a physical quantity, this phone itself is a physical quantity, the answer would be no. This is a matter. This is a matter. Why? Because it occupies some space and it has a specific mass. Clear? But sometimes we can see love, affection, anger, so many things are there. These are not the physical quantity. Because why? Because we cannot measure the amount of love. We cannot measure the amount of anger. We cannot measure the amount of happiness. So these are not the part of a physical quantity. And whenever we are going to calculate any kind of physical quantity, let's say I went to one grocery shop and just purchased some potato. Let's say 10 kg potato, 10 kg. So just in this figure you can see two factors. The first one is this 10 and the second one is this kg. So you can see two factors, and this 10 is the numerical value and this kg is the unit, corresponding unit. Without numerical value, unit is meaningless. Similarly, without unit, the numerical value is also meaningless. Just if I say give me 10 potato, if I say give me 10 potato, do you think that it's a complete statement? 10 means 10 gram, 10 kg, 10 piece, what? This is an incomplete statement. Now if I say give me kg potato, give me kg potato, just tell me, is it a complete statement? No, it's not a complete statement. Why? Because kg means how much, 1 kg, 2 kg, 5 kg, 10 kg, what's the amount, what you want. So only kg, only 10, these are completely meaningless. That means whenever unit will come, that time definitely numerical value will also come. I hope this point is clear. Now coming to the next point, what is physical quantities are divided into two parts. First one is the scalar quantity and second one is the vector quantity. A physical quantity, you can see scalar quantity, what is scalar, what is vector. This is a very interesting factor and this is very important also. A quantity which has magnitude and unit but no direction is called scalar quantity. I'm again repeating the statement: a quantity which has magnitude and unit but do not have any kind of direction, then it would be categorized into scalar quantity. Now the next point, what is vector quantity? A quantity which has magnitude and unit as well as a specific direction, then it would be known as a vector quantity. And in the scalar quantity, simple algebra or the basic algebra is applicable for scalar quantity. That means addition, subtraction, multiplication, division, these are the simple algebra which can be applicable for scalar quantity or scalars. And in the vector you can see the special algebra that is known as vector algebra. So in vector quantity, vector algebras follow. Alright, so in vector you can see magnitude, unit and direction. This is most important. And in scalar, magnitude and only unit. So some examples of scalar quantities are time, mass, temperature. These all are categorized into a scalar quantity. There are so many units: time, mass, length, temperature, so many things are there. Again, in the vector you can see one important term, this is direction. So what is direction actually? You have to be clear about it. As you can see, two boys are pushing this body, a block. So just you can see there is a direction, this body is moving in that particular direction. So here you can see force, these boys are applying force, and in this particular direction you can see the moment or the motion. Let's say 10 Newton force here, and the direction is in that particular direction. So it would be considered as a vector quantity. Clear? That means force, just in a line we can say that force is a vector quantity. And whenever you will discuss in the vector quantity, you can see a symbol. This is a symbol of direction. Alright, and it always follows the vector algebra. I hope these points are completely clear, and you can do the difference between scalar and vector also. Right, coming to the next topic. Next topic is rest and motion. The question is, what is rest and what is motion? This is very important. Just see, what is rest? What is the definition of rest? A body is said to be rest if it doesn't change its position with respect to its immediate surroundings. That means you can see no change of position, no change of position with respect to immediate surroundings, and here change of position in the motion. What is the definition of motion? A body is said to be in motion if it changes its position with respect to time. So that would be known as motion. Alright. Now the most important point is, nothing in the world is completely rest or nothing in the world is completely in motion. Whatever we are considering about rest or motion, just we are doing with respect to something. From this figure you can see these are the body which is rest. Just this house, this tree, this lamppost, all are in the rest. But with respect to something, with respect to some what say condition. But here you can see motion. You can see a man is walking and a bird is flying. So these are also in motion, but with respect to something. So rest and motion are relative to each other. This is the last conclusion. Rest and motion are relative to each other. I hope this point is clear. See, what is distance and what is displacement? So what is distance? At first you need to understand about it. After that I'll discuss about what is displacement. The definition of the distance is the total length of path through which a body moves. The total length of a path through which a body moves is called the distance. So you can see this is the starting point and this is the final point or the ending point. So from A point to B point, the path is this dotted line. Clear? This dotted line is the path. So the total length from A to B with the help of this dotted line, dotted path, whatever you can say, is called its distance. Alright, and let's say from A to B the length is the total length, I mean to say the distance is 10 kilometer. Why? Because it's a distance, it's a length, so that's why here would be 10 kilometer, let's say. Clear? And what is displacement? The definition of the displacement is the shortest distance, between the 2 points are called displacement. That means from point A to point B, the shortest distance. So how you can calculate the shortest distance? What you have to do, you have to join the initial point and the final point with the help of a straight line. So you will get the value of displacement. Here you can see in the distance its direction is always changing. First time this is the direction, after that you can see this is the direction, after that this is the direction. So there will be no specific direction. Can you see any specific direction? No sir, no direction, right? So that's why the distance is a scalar quantity. What kind of quantity it is? It is a scalar quantity. And in the case of displacement, you can see there is a specific direction, so it would be in the category of vector quantity. And if that is 10 kilometer from A to B, then definitely the value of the displacement will be less than 10. So let's say that is 7 kilometer, but definitely there will be one direction. I hope this point is clear. What is the SI unit of distance? Although distance and displacement both are length, that's why the SI unit will be also the length, the unit of the length. That means in SI the distance, the unit of the distance is meter, and displacement will be also same meter. Clear? In CGS, centimeter, here also same centimeter. I hope this is clear. From this figure it's quite clear that the distance is always greater than displacement, right? Actually, the distance is greater than or equal to displacement. Now the question is, whenever distance will be equal to displacement? The answer is whenever a particle will follow a straight line, or whenever particle will go through a straight line, that time the value of the distance will be equal to displacement. I hope that is clear. Sometimes you will see the value of the displacement is 0, but it has some distance. So what is the condition? Whenever such kind of point will come, the displacement is 0, but distance is present. That is very simple. Whenever the initial point of a body and the final point of a body will be in the same position, will be in the same point, that time you can say that the value of the displacement is 0, although it has some distance. That means whenever initial point and final point will meet together, that time displacement is 0, but it has some distance. In a circular path, you can say the same example. I hope this is also clear. So thanks for watching this video. Have a great day. Tata.